So we just did the mini lesson on parallel lines. We're going to now look at perpendicular lines. If you did the practice problem, which hopefully you did, on the parallel lines, you should have gotten y equals negative 2x plus 9. If you didn't, then stop this or pause the video and take a look at the work I have shown here. So perpendicular lines are lines that intersect at a 90-degree angle, and you'll often see that noted with a box in the corner of two lines intersecting. So here we have two perpendicular lines. We'll call the first one line 1 and the second one line 2. Let's find their slopes and see if there's anything special about theirs. If you'll remember, parallel lines have the same slope. So let's look at perpendicular line slopes. Line 1 has a rise of -1. We go down 1 and a run of +2. Going over 2. So its slope is -1/2. Line 2 has a slope of, we're rising 2, running +1. So the perpendicular line slope relationship is maybe a little bit tougher to see. First of all, I hope you noticed that line 1 slope was negative and line 2 slope was positive. That should always happen, that the signs of perpendicular line slopes are different. Next, let's take a look at the numbers. So line 1 slope was -1/2. However, line 2 was +2/1. I hope you see that the 1 and 2 switched places. So we not only have slopes that are opposites in their signs, but we also have slopes that are reciprocals. So perpendicular lines have slopes that are opposite reciprocals. Let's take a look at their equations. So this was line 1, line 2, and we'll practice with slopes in just a moment. So we found line 1 slope to be -1/2. So if we know its slope is -1/2, we can put that in the m part of mx plus b. And its y-intercept is up here at +5. Line 2's slope was +2, or 2/1 is fine, but we'll just write 2. And its y-intercept was at -1. So here we have slopes that are opposite reciprocals, and their y-intercepts are, again, different from each other. That will usually happen, but it's okay if the y-intercept is sometimes the same for perpendicular lines. That actually will only happen one time, and that would be if your line's intersection was at the origin. Both would have a y-intercept of 0, but you'll usually find perpendicular lines always have different y-intercepts. So let's practice this whole opposite reciprocals thing with finding slopes, because if we're writing equations of perpendicular lines, we're going to need to be able to write their perpendicular slopes. So if one line has a slope of -3, we can really think of that as -3/1, meaning that the perpendicular line slope, this is the sign for perpendicular, would be written as a positive 1/3. If the slope is 2/5, the perpendicular slope would be, well, flip your numbers and take the opposite sign, so -5/2. Lastly, -1/3 becomes positive 3/1, or just 3. Okay, so now we know how to find perpendicular slopes. Let's actually write the equation of a line that is perpendicular. So write an equation in slope-intercept form of the line that passes through the point 4, 0 and is now perpendicular to the graph of this line. So we saw this line's equation earlier in our parallel line example. So it's important that we start by finding the slope of the line. So it's in standard form. Let's go ahead and make that transition to slope-intercept so that we can easily find its slope. And we did do this once before today with this exact same equation. Divide everything by -3 And we get this to be this equation of the 4x minus 3y equals 2, but in slope-intercept form. Remember, the whole point of doing this is to find the slope of that line. So if the slope of this line that's given is 4/3 and we want the perpendicular line, then what we need to do is take the slope of 4/3 and now find its opposite reciprocal, meaning change the sign and flip where the 4 and the 3 are. Circle that, make a note of it because we're going to need it later. We now need to write the equation of the new line with the point 40 that has now the perpendicular slope of -3/4. So now we have a point of 40 and a slope of -3/4. And that easily goes into point slope form. Okay, it was asked for in slope intercept. So lastly, let's transform to that format it was asked to be written in. So let's simplify y minus 0 to just y and distribute our -3/4.
Middle school, your parent-teacher conference is now over. Please check the lost and found, and thank you for coming.
If you can't tell, I'm making this video on conference day. Okay, so we've now written, and I didn't even do that right because I was distracted, so let me fix this. -3/4 times -4 is +3. So what we've done is we've now found the equation of the line that is perpendicular to the one that was given. So this was the one that was given. So again, if we do a quick sketch of this, its y-intercept was at -2/3 and it had a positive slope of 4/3. So if we were looking for the one perpendicular to it, what we're saying is now this line going through the point 40, let's estimate that to be about right there, would have a y-intercept of +3 and a slope of negative, I don't know why my pen's not working, but -3/4. So if I were able to use my clicker right now, I would draw the line going through here. So just try to envision it, but you can see by our estimation that it really would give us a perpendicular or right angle perpendicular intersection. All right, lastly, it's always a good idea to check your equations by graphing y equals -3/4 x plus 3 and the original line given to us y equals 4/3 x minus 2/3 in our calculator and just verify that they really do look perpendicular. And that's just going to be an eyeball test in your calculator, but it is a good way to make sure they're looking like they have a 90-degree intersection. So that's perpendicular lines. Basically, the only difference from the parallel line process is that instead of using the exact same slope that was given to us in the original line, we take that slope and find its opposite reciprocal. With that opposite reciprocal slope and the new point for the new line that it's going through, we create a new equation. You now have a practice example that you can work out on your own, and tomorrow we will do more practice with parallel and perpendicular lines.